The toilet tank exists because waste removal cannot be optional. For most of human history, sanitation was passive. Waste was moved away from living spaces by distance, burial, or time. Latrines relied on depth. Chamber pots relied on disposal rituals. Early drains relied on slope and chance. These systems worked until population density increased and proximity became unavoidable. As cities grew, the problem changed. Waste was no longer something that could be ignored between uses. It had to be removed immediately, consistently, and without exposing the user to the process. Early flushing systems attempted this, but they struggled with reliability. A small amount of flowing water was not enough. Waste clung, odors returned, pipes clogged. The system needed not just water, but force. The toilet tank emerged as a solution by separating collection from release. Instead of depending on constant pressure from a water source, the tank stores water above the bowl. This stored mass creates potential energy. When released, gravity turns that stored energy into motion all at once. This is the key insight. Flushing works because of sudden volume, not continuous flow. A trickle cannot clear a bowl reliably. A surge can. The tank's size reflects this requirement. It must hold enough water to create a complete reset of the system. Too little and waste remains. Too much and infrastructure is strained. The familiar proportions of a tank represent a compromise between certainty and efficiency. Height matters as much as volume. The tank must sit high enough to create momentum, but not so high that installation becomes impractical. Early toilets emphasized height dramatically, with tanks mounted near ceilings. As engineering improved, siphon designs reduced the need for extreme elevation, but the principle remained. Inside the tank, every component serves timing rather than power. The fill valve controls recovery. The float controls readiness. The flapper controls release. These mechanisms ensure that flushing is decisive and refilling is gradual. This distinction reflects human expectations. People tolerate waiting afterward. They do not tolerate uncertainty in the moment. The flush must work immediately, even if preparation takes time. The tank also isolates the user from the water supply. This matters more than it appears. Direct pressure systems risk variability. Pressure fluctuates, demand changes. The tank ensures consistency regardless of conditions elsewhere in the building. Human behavior again shapes the design. Toilets must work for distracted users, tired users, hurried users, and children. The interface must be obvious. Push or pull. Everything else is hidden. The sound of the flush reinforces trust. It confirms action. Silence would feel suspicious. Excessive noise would feel violent. The familiar rush communicates completion without demanding attention. As concerns about water use grew, the tank adapted rather than disappeared. Dual flush systems, low-volume tanks, and pressure assist designs all preserve the same underlying logic. Store energy, then release it decisively. This persistence reveals the tank's true function. It is not primarily about water. It is about control. Control over timing. Control over outcome. Control over hygiene. The moment of realization comes when you understand that the tank exists to protect the user from doubt. It ensures that one action produces one reliable result every time. Without the tank, flushing becomes conditional. With the tank, it becomes assured. At the end of a flush, the tank quietly refills, resetting itself without involvement. The user is not asked to monitor or adjust. The system restores readiness invisibly. Invisible design often works by removing uncertainty from moments people don't want to think about. The toilet tank does exactly that. It turns a potentially uncomfortable process into a forgettable one. If the tank is doing its job well, you never consider it at all, and that is the mark of its success.